Okay, on problem number 8 here, what we have is a car that looks magenta in the sunlight, which is white light. So let's start off with a magenta car. Here we go. We have a car that is magenta looking. And what we have to remember is that white light can be thought of as simply being a combination of sunlight coming in with red and green and blue light. Remember, those are the three receptors we have in our eyes. Now, magenta is produced by combining just red and blue. So what happens is, therefore, what goes into my eyes is the blue light and the red light bounce off of this and go into my eye. Which, let me draw my eye. So here's my eye. And so what I'm seeing is the red and the blue. What I'm not seeing is the green. The green got absorbed by the car. So the answer here is, what pigment was absorbed? And the answer is, the answer is green. Now, what color would the car look in blue light? If we only shine blue light on the car, well, magenta is a combination of red and blue, so the blue light would bounce off the car and go into my eyes, so the car would look blue, not magenta. What color would it look in green light? Well, let's just take a look at this. If green light came in, remember, magenta is a combination of red and blue, so it absorbs green. Remember, we said here it absorbs green. Since it absorbs it, I wouldn't see any color, in which case what I would find is that it would look black. Now, in red light, what I would find is magenta absorbs green and reflects red, so when I looked at it, I would see red. Now this is more interesting. What color would it look in yellow light? Now let's recall that yellow is what we see when both our green and red sensors are stimulated. But remember, this car is a magenta color car because it absorbs green. So it will absorb this green, leaving only one color to go into my eyes, and that color is red. So on question 9, I have a shirt, and this shirt, let me finish drawing it. Okay. Alright, this shirt, it turns out, is one that absorbs the wavelengths that simulate my red and blue cone cells. So let's have white light shine on it. So what we have here is, we have white light has red that comes in, it has blue that comes in, and it has green that comes in. But of those, what color would it look in white light? Since what's being absorbed here is, it absorbs the red and absorbs the blue, what that leaves to go into my eyes is green. It would look green. What color would the shirt look in blue light? Well, since it absorbs blue, it would look, let me just change my color here, it would look black, because it's going to absorb the blue. The blue comes in, but it gets absorbed. What color would it look in yellow light? Now, if we recall, yellow light is both red and green. Now, the red gets absorbed, but the green would bounce into my eyes. So in this case, what I would see would be, let me change over, a green shirt. Now, I wish I hadn't asked number 10, because number 10 says, if grass is green, what colors does it absorb? 9 kind of gives that away. So basically what happens with grass is we have green, well, here let me just draw, there's a grass. So green and red and blue hits it, but the color that goes into my eyes is green, so what that tells me is it absorbs the red and the blue.